let's talk about finding intercepts from equations. So first of all, what are intercepts? Any point where a graph crosses or touches an axis is called an intercept. These points will have then a zero as either the x or y coordinate, because points on the x-axis have a y coordinate of 0, points on the y-axis have an x coordinate of 0. So that having that 0 as a coordinate gives us the tool to find those intercepts if all we have is the equation. So to find the x-intercepts, you plug in 0 for y and solve for x. To find the y-intercepts, you plug in 0 for x and solve for y. Some notation, things to be aware of with MATLAB. If you're asked to find all intercepts, you need to give it ordered pairs, and it'll say to give ordered pairs. And if you just list the x and y values, not in ordered pairs, there's no way to tell whether each one of those is an x value or a y value. So it's super important to give the ordered pairs in that situation. On the other hand, if MATLAB asks you separately for x-intercepts or asks you for y-intercepts, then all it wants is just the x value or the y value. And there might be more than one that you list, but it's not an ordered pair. And it'll count wrong if you give it the ordered pair. In this case, in my opinion, the ordered pair isn't wrong. It's just not what it's asking for. It's more information than necessary. But that's what MATLAB wants. So if it doesn't say type an ordered pair, then don't type an ordered pair. So finding intercepts, we're going to find some intercepts and use them to graph and talk a little bit also about some types of graph. So this type of equation we have here, 5x plus 2y equals 10, is a linear equation. So we have basically these three terms, a multiple of x, a multiple of y, and just a number. Any equation that's made up of just those types of terms is linear. So it doesn't have any squares or cubes, any other powers of x or y. It doesn't have x's and y's being combined with each other with multiplication or division or anything. It doesn't have square roots of x, anything like that. So this type of equation, the graph is a straight line. And all you need to graph a straight line is 2 points. So often there's an x and y intercept, there's 2 points, and they're easy to find because you're just plugging in 0 for x to find y, plugging in 0 for y to find x. So if I do that with this equation, plugging in 0 for x, that really just makes the x term disappear. So I have 2y equals 10, divide both sides by 2, and I get y equals 5. The ordered pair for that would be 0, 5, but I can just plot, go to 5 on the y-axis, and there's the point. So if you're just asked to list the intercepts, so far we have the point 0, 5. If you're asked for the y-intercept, that you would just put 5 as the answer. All right, then if I plug in a 0 for y, 5x plus 2 times 0 equals 10, that really just makes that y term disappear. So I have 5x equals 10, divide both sides by 5, x equals 2. So if I'm just asked for the x-intercept, the answer I give is 2. I mark 2 on the x-axis, that's the point, but the actual ordered pair is 2, 0. So if I'm listing all the intercepts, I have now 0, 5, and 2, 0 as ordered pairs. If I just list 5 and 2, then there's no way of telling which is which just from looking at those answers. But with those 2 points, I can then have a line connecting them, and that's the graph of the equation. Then a second example, here we have the equation y equals x squared minus 4. This is a quadratic equation. It has that square, doesn't have any higher powers of x or anything else weird going on. But it's a quadratic equation. Its graph is going to be something called a parabola, which is this sort of a U shape. So a couple things to know, though, with that is the turning point of the U shape is always going to be, if there are x-intercepts, it's going to be halfway between. So if you find the x-intercepts, that kind of helps tell, that turning point is going to be way off somewhere. Now a parabola can have no x-intercepts, and then that doesn't really help. But if it has x-intercepts, that turning point, that's kind of the focal point of the graph that you need to have the complete graph. It's going to be located there in between the x-intercepts. So finding the intercepts of this equation, plugging in 0 for y and finding x. So that's going to give the x-intercepts because I'm finding x values. X squared minus 4 equals 0. I have a couple ways I can solve that. I can add 4 to both sides and get x squared equals 4 and use the square root property. Plus or minus square root of 4 is 2 and negative 2. Or I can factor and get x minus 2 times x plus 2, since this was a difference of squares. Then x minus 2 equals 0 and x plus 2 equals 0 gives those same two values. So if I'm just asked x-intercepts, I just list 2 and negative 2, or negative 2 and 2. Either order doesn't matter, but I'm just listing those x values. On the graph, I mark negative 2 and 2 on the x-axis. But when I'm asked to find the intercepts, I have to list them as ordered pairs. So I have negative 2, 0, and 2, 0. Or I could list them as 2, 0, and then negative 2, 0. Again, the order of the individual intercepts doesn't matter as long as I have the right order within the ordered pair. But then I also need the y-intercept. So I'm plugging in 0 for x and find y. So 0 squared minus 4 is 0 minus 4. So we have y equals negative 4. So negative 4 on the y-axis. If I'm just asked again for the y-intercept, I just would say negative 4. When I'm listing all the intercepts, I need the point 0, negative 4. So those 3 points listed in any order to answer find the intercepts, but just the 2 and negative 2 for the x-intercepts, the negative 4 for the y-intercept. So the turning point is halfway between the x-intercepts. That means the y-intercept here is in fact the turning point, and so that's the lowest point. But I could fill in also, if you needed, you could find other points. So maybe what about if x equals 1, then y is 1 squared minus 4, which is 1 minus 4, which is negative 3. So we have that point there. You can see, well, that's above. Negative 1 is going to come out also. Squaring negative 1 and subtracting 4 is again 1 minus 4, which is negative 3. So we have that point. If I go 3 squared minus 4 is 9 minus 4, which is 5. So we have 0.35 here. And then we would also have negative 3, 5. Square of negative 3, again, is 9, minus 4 is 5. But that's the shape. If you know where the vertex, so that turning point, once you know where that is, then it's easy to come up with the rest of the graph. Well, particularly that, and at least one other point is enough. So that is intercepts from an equation, and then using those to graph the equation.